Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is diesel emission systems operation and testing. And boy, that's a mouthful, but we're going to be focusing on not like, say, heavy duty big rig type diesel emissions, even though it's similar. We're of course going to be focusing on the 1 ton and under crowd here, talking about a bunch of different things like DPFs and SCRs and all sorts of things. So let's get into it. So there's a couple different ways that OEMs control diesel emissions. One way is in the combustion chamber. So they can do that with chamber design by changing the amount of swirl, fuel atomization, where they spray it, how much they spray, injection timing, EGR, boost level with the variable geometry turbo, engine temperature, and compression ratios, and more. So that's inside the combustion chamber. That's kind of unique per OEM or engine manufacturer anyways. Now, as far as post-combustion, oxidation catalyst, diesel particulate filter, and selective catalyst reduction system, all three of those kind of work in tandem, and there's a lot of other sensors and things that go along with this. And they're all going to be fairly similar. I mean, sometimes the SCRs first, sometimes the DPFs first in line. Some other variances, but they all use some combination of all of this stuff we're going to talk about. So it starts up here with the variable geometry turbo and the EGR. So there's the EGR valve there. There's the EGR cooler. And then we have the variable geometry turbo, which helps with the EGR. And then we have the dosing injector for the DPF. That's to increase the temperature on the DPF itself. We have temperature sensors, multiple temperature sensors along the way. We also have a differential pressure sensor. So that is a DPF differential pressure sensor. So it measures the inlet pressure and the outlet pressure and see what the difference is. So it knows whether or not how much soot is in there, how much it should be flowing, whether or not the regen has been finished, that sort of thing. Multiple NOx sensors as well. So NOx, NOx, oxides of nitrogen. So one before the SCR and one after the SCR, so it knows how that's working. We're going to talk more about that in a little bit. So the diesel oxidation catalyst takes the diesel fuel that lights up the DPF. Then the after oxidation catalyst is going to be after the SCR. To go into the SCR, we're going to have a injector that injects the diesel exhaust fluid. And we're going to talk more about that in a little bit as well. But you see we got different lines and heaters and different ways to heat it up. Level sensor, temperature sensors, supply module, filters, pumps, all sorts of different things. And then it goes through the SCR system and then it goes out the back. And hopefully it's a whole lot cleaner by the time it gets out than when it came in. That's the whole gist of it. Now, introducing some of these things can cause other issues that other things mitigate. So the diesel EGR is going to slow combustion to keep NOx from being generated, which allows for more advanced injection timing. Requires the use of EGR coolers because it does get quite warm, and uses variable geometry turbos to raise exhaust back pressure, which makes exhaust flow into the intake under low boost. So it adds inert gas into the combustion chamber to keep the combustion temperatures down, which is how it controls the NOx. Now, because of this, because being exposed to combustion and all that, and the exhaust, then it will cake up. So here we have a clean one on the right-hand side, and we have obviously a dirty, clogged, sooty mess over here. And then if we look closer on this one in here, we can see the little pintle in there, but very, very caked up, clogged up, lots of oil and gunk and junk in there. So that can be a problem. The coolers can clog as well, which will reduce flow and more. So let's get to exhaust after treatment. So this would be your diesel particulate filter stuff. So soot after treatment. Oxidation catalysts, diesel particulate filter, exhaust temp sensors, multiples of those, DPF back pressure sensor or differential pressure sensor, they may call it, and a hydrocarbon dosing valve would be all part of this system. So the diesel oxidation catalyst is usually first. So it takes hydrocarbons and converts them. Oxidizes dosed fuel during active regens as well. So when it's spraying the diesel fuel into the exhaust to increase the temperature, it oxidizes the fuel. Also converts oxides of nitrogen to nitrogen dioxide, used during passive DPF regeneration as well. Then we get to the filter itself. So the filter has three main jobs. It is to catch the soot, store the soot, and then burn that soot off later once it gets collected and once it gets full enough. So it's just constantly doing this cycle of catching, storing, and then burning it off. So how does it do that? It goes through a substrate. And you see how it's kind of a checkerboard pattern. So the black holes are open, the white holes are closed to the exhaust flow. So when it goes through the open hole, the soot then gets wiped into the substrate, and then the exhaust is then free to travel out through the blocked off holes. So it's blocked off in the front, so soot doesn't get in there, and it gives it a route to escape. Now, once it gets to a certain point, though, you're going to have to clean it out, which would be a regen. But once it gets to a point like this, then you're probably not going to be able to regen it at all. You're not going to be able to clean it. It probably needs to be replaced or repaired. So in this case, this is completely clogged. You can see it's even like oozing out the front. It's so clogged. So that wouldn't allow a regen. And we'll see an example of what the vehicle would tell you in a little bit. So a few different ways of doing that. Passive regen. So that's when the DPF temps are high enough to burn the soot from the DPF without needing extra fuel. So that would be like under a high load situation, like maybe, I guess, towing a trailer or going up a steep grade or something like that. Active regen can be initiated by the PCM or by a scan tool. Extra fuel is added to the exhaust to raise the DPF temperatures to approximately 1025 degrees Fahrenheit. So it gets pretty hot. And then there's a parked regen, which is initiated by a dashboard switch or could be initiated by a scan tool. There's many static regens. Used when attempts at active regens fail. So there's your three different ways of doing it. Now, if we have a problem during regen, overheated in this case, so we can see how it got melted. So it flowed in this direction. It got way too hot and it melted, so that's destroyed. Or breaking. So just like a catalytic converter, I guess, in the same type of way. It could break, and we got chunks of it just sitting inside there. So it either needs to be replaced or rebuilt. There are places that rebuild them. We also have exhaust gas temperature sensors, multiples of those, so the computer can monitor how the exhaust gas temperatures are changing throughout the process and throughout just the exhaust system in general. And DPF differential pressure sensor. So that has, as you can see, two lines hook up to it. One's on the inlet, one's on the outlet, and it measures the difference. It's like a diaphragm, basically, that changes resistance depending on which way there's more pressure. And then the dosing valve, that would be it's like a poppet valve, and that's what it uses to spray the diesel fuel into the exhaust with that. So we can see there's a little valve there, little gasket for the exhaust, and so on. Now, the data inputs that the PCM needs to determine whether or not it needs to regen or not, what the soot load is, etc. So the differential pressure sensor, of course, that's main there. Wideband oxygen sensor, if the vehicle has it. Distance traveled, engine speed, engine load, air mass, engine temps, exhaust gas temperature, and more. This kind of allows it to calculate, okay, how much is this thing clogged? Is it 10% clogged? Is it 100% clogged? Where is it? And it kind of looks something like this. So in this case, this is the one where this is a vehicle where the SCR is first. Other vehicles, the DPF is first. I don't think it makes a huge heck of a difference, but some manufacturers like to do it one way. Some manufacturers do it the other way. We have our NOx sensors, so one there and one there, so on either side of the SCR. We got exhaust gas temperature sensor here, 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 and here. So it wants to see it before it gets to the cat, when it gets out of the cat, after the SCR, and after the DPF in this case. The SCR is there, the DPF is there, the diesel oxidation catalyst is there, and of course the hydrocarbon injector, the diesel injector, would be ahead of that oxidation catalyst because it oxidizes the fuel. DEF injector is going to be in front of the SCR, wherever the SCR is. So that's going to be the diesel exhaust fluid. It's going to pump that and squirt that into the exhaust there to allow that reaction to take place. And then DPF differential pressure sensor, as we see, it goes before and after the DPF, and it measures the difference in pressure front to back. So that's kind of a base layout of that. So the EGT sensors, in this case, we have temperature sensor 1. So that's between the turbo and the cat. This is used for comparison to the outlet to see if it lights when dosed with fuel. Then we have T2 right there, which is between the catalyst and the DPF to see if the catalyst lights when dosed. Also used for comparison in the DPF outlet to see if it's burning soot. And then the DPF outlet is to see if the DPF got hot during a regen. Also know when the regen is over, because once the soot is burned off, the temp will drop. So it's able to use multiple temp sensors, and it might be more than 3. But it allows it to just kind of check progress along the way. As we can see right there too, we also have air and fuel that goes into the injector there. So it injects the fuel in there and then lights off the cap. And then we get to the SCR, so the selective catalyst reduction system. So we have the catalyst itself, a decomposition tube, DEF injector, DEF pump and tank and lines, and whatever else is involved with that. NOx sensors, so oxides and nitrogen sensors, and sometimes an ammonia sensor. And we'll talk about why that's important. And the reason why it's important is part of the reaction that we're trying to cause in here. So we have our oxides and nitrogen here, and then we have ammonia, which is based on the diesel exhaust fluid, which is based on urea. And urea has a strong component of ammonia in there, so that's why it causes this chemical reaction. Ammonia combines with the oxides of nitrogen, making nitrogen gas and water. So both things that are prevalent in the atmosphere to begin with. So bad things in, not so bad things out. And then the decomposition tube. In this case, this is on a Cummins. In this case. So we have the particulate filter there, SCR there, so they do DPF first. The decomposition reactor, what they call it there. So that's where the diesel exhaust fluid goes in, and it mixes with the exhaust gas in here. So oftentimes there's things that increase swirl, things of that nature to allow it to spread out better for the catalyst. And there's an example of what that injector might look like. So it's in that tube there, and then we can see the clip for the line that goes there, like a quick release. And then we have the actual electrical connector there, and then some heat sinks and such. And it just bolts inside the exhaust there. So as far as plumbing, we got the tank, we got the lines, we got the pump, coolant heater, could be an electric heater for it too, level sensor in there, whatever else it might need, maybe a pressure sensor, something like that. It just depends on the manufacturer. And then we have the NOx sensors, which determine inlet and outlet NOx readings. So these would be PID data fed to your computer. So you can actually check that with a scan tool and see how it is working, whether or not it is working. Can be used in open or closed loop systems and can mis-ID ammonia with NOx. That's the important part right there, is if you only have a NOx sensor and we have an issue with too much ammonia in the system, it could say, oh, I got too much NOx in the system. And then maybe add more ammonia and so on. So that's why some manufacturers also have an ammonia sensor. So NH3 is ammonia. So measure ammonia levels after the SCR, allows much greater NOx regulation, and it is immune to other exhaust gases. So it's not going to misidentify other gases as ammonia. So how it works, long and short of it, we have the inlet NOx sensor, we have the injector, and we have the outlet NOx sensor there. So this is the diesel oxidation catalyst. That's the DPF in this case. That's the injector. That's the SCR itself. And then we have a slip catalyst at the end over here to kind of clean up whatever's left. Now, in order to diagnose an SCR system, you're going to want at least a scan tool that's able to read PID data on the vehicle. But a good sanity check, I guess you could say, against what the computer's saying, what the computer's thinking, would be to have maybe a 5-gas analyzer. Or actually, we'll talk about in a little bit. We just, maybe 2 years ago, released a single gas analyzer too that just reads ammonia. So this, or yeah, just reads NOx, sorry, to check for ammonia. So it reads NOx, or we want to read NOx. So a couple different ways this works. So in this case, we have at warm up with the injector off, it's not doing anything. It's just sitting there warming up the exhaust. So PID data is going to be NOx in at 300, for example, not necessarily a hard and fast number, but, and then output is reading also 300 parts per million. And then if I double check it with the NOx sensor or the NOx 5-gas, it's going to read 300 parts per million. So that's kind of a sanity check on this sensor right here. So nothing's going on. It's not spraying anything. So we should see, it should just be the same going right through. Under normal operation, we have NOx coming in at 300 parts per million, measuring out 30 parts per million. We can see the ammonia's in there, and then the sanity check down here for 30 parts per million once again with the NOx 5-gas analyzer. We can see that everything's doing what it's supposed to do. It's never going to get to 0, right? But that's a 90% reduction from 300 down to 30, so that's pretty good. Total failure, it's going to read PIDs of 300 in. The injector would be spraying, and the out PID would be reading, in this case, 600 parts per million, so it's basically doubling up. But if we measure it with the 5-gas and we see 300 parts per million, so we can see 300 coming in, 300 going out, we know the injector is working, so that means the SCR is not doing anything at all. And once again, that could be because typical NOx sensors not only read oxides and nitrogen, they can also monitor ammonia, which can give false elevated NOx parts per million readings. So in this case, there's one that just went way over for no good reason other than the fact that it misidentified it as ammonia. And here's an example of a partial failure. So I got reading PIDs of 300 in, PID of 300 out, but then actually measuring it 150 parts per million. So it's doing half a job, but it's not doing the entire job. Right? So that's your sanity check to see whether or not it's working, like I said. Now, easier to find fault in the system with reading the NOx from the tailpipe, like I said, with a 5-gas. So, like I said, we also have this Blue Point branded one that only reads NOx. So that's what exactly what this is designed to do. It's designed to read only NOx just for this type of application. So it's a fairly specialized thing, but there's enough SCR systems out there, and they're not, I guess, not the easiest to diagnose necessarily. So they give you even an example chart, which is nice to go with it. So for example, this would be my PID data, NOx sensor 1, NOx sensor 2. So sensor 1 reading 400, sensor 2 reading 40, the analyzer reading 40, so the gas analyzer reading 40. That means everything's doing what it's supposed to because that checks that. 400 in, 90% reduction, looking good. Now let's say we had 400 in, reading a PID of 800 out, and then seeing 400 in. That means it's totally failed, right? Because the 400 is just getting right through. But it's reading 800 because the injector is spraying, and it is reading the excess ammonia, right? Let's see here. We got 150 in, 300 out, and it's checking at 300 out. That means NOx sensor 1 is not reading correctly because it's low. It's reading way lower. It should be 300. 600 in, 400 out, and then you're reading 10. That means it's actually working, but that second sensor's failed on the high side. 400 in, 400 out, reading 400 means I probably have a DEF issue. It's not injecting DEF or it's contaminated because it's not doing anything. But if you know it's spraying, right? And then 400 parts per million in, 400 parts per million out, reading 250, it's partially failed, right? So it's probably the cap in that case. So these are just, as I said, a guide only. Your mileage may vary, not actual true readings that you really need to care about. So, yeah, that is my slides. So let's go to the tool. walk through a couple vehicles. So first one I want to do is this Mercedes Sprinter. Some of them are only available with a diesel engine. Sprinter, there we go. So what trips some people up sometimes, because we do get calls on this, is looking for the DEF system, right? So on Mercedes, they call it AdBlue, right? So there's many different names for the fluid. So you have like Blue Def here. I know you can buy like that in like a box at the store. There's numerous different names. AdBlue is actually a trade name, brand name, but that's just what Mercedes calls that system in as kind of a general, kind of like a Xerox type situation, Kleenex type situation. So they just call it AdBlue system. And I think it's way more popular over in Europe to call it AdBlue because you don't really hear about it over here. It's more of just like the DEF system or the urea or whatever. But on the Mercedes, there is a separate category for engine-related systems and controls for diesel. And the selective catalyst reduction system is there, AdBlue. So we'll go in there. Just going to pick the first one. And you see we got codes, data, functional tests. If we go into special functions, there is a reset and calculated fill level, AdBlue return, visual leak test, dynamic test at a delivery pump. And then actuator tests, switchover valves, metering valve, delivery pump, tank heater, set the metering valve to 50, set it to 5, pressure line heating element, delivery module heating element. So it's got a lot of stuff in there. Let's look at the data. So we got fill level data, AdBlue temperature data, temperature values data, test values while driving, and AdBlue metering data. And then since it's a Mercedes, we got to cycle the key when we leave the module. Always make sure you follow instructions. Don't want to brick a vehicle. And then the rest of the stuff is going to be under just the engine control module in this case. So I'll do this one. Goes down to functional tests, special functions. We have adaptations in here. So some of these apply, some of these don't apply to the diesel emissions, but let's see. So we got replacement of DPF pressure sensor, teach-in after oxygen sensor upstream, oxidation catalytic converter. Let's see, teach-in use DPF, reset learn values of NOx sensors. So when you replace a NOx sensor on this, you need to relearn it. Teach-in process at a replacement of SCR, replacement of temp sensor upstream of SCR, after replacement of AdBlue metering valve, regen the DPF while driving. So replace the DPF. So there's a lot of different adaptations in here with that. And output controls, nothing in there. Oh, EGR, I guess, actuator. So we did mention EGR. And then also has injector programming. So if I needed to program the injectors on this, fuel injectors, not the DEF injector, and I know it's not necessarily 100% related with emissions, but many diesel vehicles need this operation done, and the manufacturers call them different things. So when replacing injectors, it's essential to save the QR code of the new injector, the engine control unit. Process ensures the necessary correction parameters of the injector will be recorded in the engine control unit. Correction parameters enable the engine control unit to meter the injection quantity precisely. So it's a 7-character QR code located on top of the injector. So you go through, it's going to tell you what you have, what's in there. So let's say I wanted to change this out. 1, 2, 3, 4, 5, 6, 7. Okay. So it's a 7-digit thing. There's the old one. There's the new one. Hit OK. There's the old one. There's the new one. Hit program. And it'll be in there. Right. Done. Easy enough. And then also on many vehicles, if you have the guided component test function on your tool, which be any of our tools with a scope, you go into engine, there's going to be other things like DPF differential pressure sensor right there. So it's going to tell it how it works. It's going to show us the pinout, tell us what colors the wires are, located in the right front of the engine compartment. And we can do a voltage test, checking for 5-volt reference, checking for ground, outer range no signal tests. Let's see, what do we got? EGR system. So back pressure sensor, cooler switchover valve, temp sensor, valve actuator, NOx sensor. So that kind of tells you how it works. Use this information to determine the amount of depth required. Control units located downstream and upstream of the cap. And then it's got the pinouts there, pin assignments, of course. Runs over CAN. So if we do a signature test, we should see a CAN pattern on there. Let's see. Oxygen sensors would be that. Pressure sensor, air filter though. Temp sensor, DPF. Temp sensor upstream of the SCR. Temp sensor upstream of turbocharger. So we got all these different temp sensors. Right, it's going to tell you exactly where it is. So all sorts of good information. And then you can test it. Next one, we'll go to a Ford. Do an F350 this time. And on Ford, they do not have a separate section down here for engine-related controls. So all of that is in the engine control module itself. We go to functional test, special functions. We got our DPF dynamic, DPF static, so we can do it either driving or not. And this one actually kind of gives you a good indication of why you might not be able to do a regen if you want to, even if you want to. So command DPF regen. A manual regen may take up to 1 hour to complete. For static, the test will increase the engine speed to a high RPM for an extended period of time. For dynamic regen, the test will require the vehicle to be in motion for the duration of the regen. So continue. Warning, always perform the DPF manual regeneration procedure outside. The exhaust system, adjacent components, and exhaust outlet temperature are very hot during this procedure. Don't park it near a pile of leaves either, which increases the risk of personal injury. Keep people and combustible materials away from the hot exhaust system. They just want to confirm again that you understand that it's dangerous. Turn the ignition on. And then it's going to give you a soot load. So in this case, on a Ford, it gives you a soot load and tells you a percentage. So 50 to 99% is partially soot loaded. 100 to 120 is fully. 121 to 199 is overloaded. And above 200 is fully clogged. So this says 771 because it's a simulator. And it is not going to let me pass. Percentage of soot load is higher than the maximum limit to perform a DPF regen. To prevent dangerous overheating of the diesel particulate filter, the DPF regen has been disabled. So it's just you're gonna try, and it's not gonna let you because the load is too high. SCR stuff. So you got dosing measurement, system emptying, refilling, visual leak check. Fuel injection corrector factors would be the fuel injection programming that we talked about earlier, coding. Yeah, reset and clear specified functions. I think this gives me a list, right? Yeah. So particulate filter, differential pressure sensor. These are all clearing adaptives, basically. EGR, initialize SCR learning, NOx sensors, oxygen sensors, reset particulate matter sensor, learn values, etc. So lots of stuff in there that may be with the emissions. And then also on the Ford, we will have some guided component tests too. So things like the diesel emissions control is kind of lumped into one. So DPF differential pressure sensor, reductant pumps. So anything that says reductant is going to be your SCR system. So you have the injector and the line heater, etc. So let's look at the injector. It's a 2-wire injector. Pulse width modulated in this case. And let's go with a Silverado. So in this case, this does have that separate section. However, it is not related to emissions. So it's glow plug and power takeoff. So if we go into engine. So it has separate DPF tests. So regen enable, service regen, pressure sensor reset, and catalyst reset. And then reductant system. Once again, if you see reductant, then it's going to be the SCR. Tamper warning. And then in module setup, there is the injector flow rate programming in there. And then if we go to guided component tests, there's a bunch in here too. So diesel emissions controls again. There's your DEF injector, purge solenoid, and the hydrocarbon injector. So that'd be the one for the DPF that injects diesel. Let's see. Looks like that's about it on that one. And then finally, we got this little Jeep. Got a little Jeep Renegade here, which actually 2 different diesels could have. In this case, we're going to look at the 2-liter diesel. And that's behind security, of course. Okay. And this one also has a separate thing going on. Here's the dosing control unit, but that doesn't have any functional tests. It's just codes and data. So if we go into engine and we go to miscellaneous, you can see differential pressure sensor replacement, EGR high pressure valve, low pressure valve replacement, particulate filter with integrated pre-cap replacement, particulate filter regen, injector replacement, VGT, NOx sensor. So lots of different resets for those. Oops, I went too far. System tests, EGR high and low pressure valve tests, VGT actuator tests. That looks like it for emissions. And then functional tests. We're going to have EGR cooler bypass, turbocharger pressure actuator, variable, let's see, DPF lamp, I guess. So that's about it on that one. And I know this one does not have any guided component tests. So this particular engine. So with that, that's diesel emissions in a nutshell. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week and we'll see you on any of our other videos. Have a good week, have a good night, and take care.